Welcome back. So now we're going to close out the lecture with Reza. So Reza, welcome back. Your research is actually mostly tied to ethical ML, but specific parts of it. So what are the major topics or problems that your group is trying to solve?
Yeah, so there are two major types of problems that we work on in this area. The first is about understanding and quantifying the risks of machine learning models, whether models are leaking information, whether they are robust or not, whether they're fair or not, and to what extent. When we talk about privacy, when we talk about fairness, um, these are some concepts, and we need to come up with quantifiable metrics that can measure the privacy risks or the fairness risks of a machine learning model. And then the second set of problems are about techniques that can preserve those properties, algorithms that we can design to make sure that the machine learning model is privacy preserving or is fair, is robust, or is explainable. So if I want to give you examples on this, one particular example is that we have designed algorithms that can show machine learning models can leak a significant amount of information about their training data by just having access to the model predictions, for example. You can tell whether a particular data was part of the training set or not. Unless the model is trained in a privacy preserving way, the complex models, for example, deep neural networks, are very vulnerable to these kind of problems. And then talking about defenses, consider the scenario where you have data, some other entities also have data, and you would be interested in training a model jointly, but of course, because of the privacy reasons, you don't want to share the data. And also, you know that anything which is computed on the data might leak information about it. So this is something that we came up with a few years ago on designing a framework which is known as Federated Learning today, that enables different parties to share compressed information about their data in a privacy preserving way, enabling everybody to benefit from everybody's data without leaking significant amount of information. So we work on this both assessments and defense mechanisms for all these different pillars of trust.
Yeah, that, to try to deal with so many multiple parties, I guess, is the heart of the problem in the federated machine learning context. I wanted to go back to one of the other concepts that you introduced earlier, which is trustworthy ML. So I understand you're also able to talk a bit more about, what are the main challenges, especially what your group is looking at when it comes to achieving trustworthy ML.
Yeah, so the major challenge is that there are some trade-offs between different properties that we expect from machine learning models. So if you expect a model to generalize very well, that requires the model to have a good capacity, a large capacity to enable searching the space to find the optimal model. But the same capacity would make the model more vulnerable to information leakage or basically data manipulation attacks. A larger model would remember more information about the training data and could leak that information. Also, there are trade-offs between different aspects of trust. For example, we have shown that when you are designing a model explanation for a deep neural network, then that could also leak information about the training data. So you want to make the model more transparent, but also you leak more information. The challenge is how to make a model generalizable, interpretable, and privacy preserving. Or in another example, we have shown that when the models are trained to become more fair, they actually become more susceptible to data poisoning attacks, because the attacker would be able to craft data that has way more influence on the final model compared to the models which are not fair. By definition, the models which are not fair ignore part of the data notably the outliers. The fair models would just give equal value to all data from different groups, and this could be exploited. So all in all, the challenge is how to design algorithms that satisfy all these different aspects in a consistent manner.
Right. It's really helpful for our students to have this larger context, especially in their first course on machine learning. And learners, you can think about what Reza is talking about and how you would be able to realize that in a system like a deep learning system that uses gradient descent would, need a loss function that encompasses some of the criteria that Reza has brought up for us. And so, with that, first I want to thank Reza for sharing his insights with us. And unfortunately, that means our time in our course is finished. We've come to the end of our whirlwind tour in machine learning. And so, after this, you'll have a bunch of revision lectures that you can watch. While you don't have to watch them all this week, it's not compulsory. We suggest that you watch them as you're revising for the course, in those short 3 to 4 minute vignettes to just jog your memory. As we know, human learning helps to have spaced repetition. So, we're talking about machine learning, but we also want you to worry about your metacognitive skills. Okay, so thanks everyone, and we'll see you at the final exam.